Hi everybody, I'm Mate and I'm working at Skyscanner in Hungary, and today I'm gonna talk about Android development. Switch on. Okay, sorry. So, it's okay? Okay, so I'm gonna talk about Android development, Kotlin development. I have been told that everybody is familiar with Kotlin, so I won't be going into the basics. I'm gonna talk about Anko, which is a library for building for Kotlin. I'm gonna start with the feature of Kotlin language, which actually makes Anko possible. And then I will talk about Anko overview, what can you achieve with it, and then before I go through the features of Anko, I'm gonna go into some details, how it is implemented, and then obviously we go through all of its features, the pros and cons, how can you implement what you want to achieve, and then at last I will be just going through, if I will have time, the non-UI builder features of Anko. So I'm gonna start with the question: who is familiar with Kotlin? Not so many people. Then maybe the presentation will be a bit deep because it uses Kotlin, but the syntax of Kotlin is pretty straightforward. So you are gonna be able to understand, hopefully. Okay. So what is Anko? It is a library within Kotlin, and the aim of the library is to empower Android development in Kotlin by having these type-safe builders for UI, and there are some convenience utilities to make some Android-specific features more easy to write and read. So, before we get started, let's check this language feature of Kotlin, which is unique, and it has make type-safe builders, and Anko is heavily built upon type-safe builders. As I'm aware, there will be a whole presentation about type-safe builders at the end of this day. So I'm just looking at the basics here. So what we want to achieve here is that we would like to have this initializer block for a specific type. So after we construct an object, we would like to set its properties, configure it in a convenient way. The naive implementation would be this. This is actually useless. You create a person object and then set up the person name as John. Obviously, you could just write a person that named John. So here there is no use of using this method. To make it one step better, is actually define the apply method as an extension function over the T type. Here you don't have the person as a method parameter, at least syntactically, but it acts like if it were a method inside the person class, and then you can use the same lambda to set up your person. But actually with Kotlin we can achieve more, so we can write a lambda where you're inside the context of the person. So in the last sample, you had the t as a parameter of the apply method, and you can use that parameter to configure your object. And here, this construct is called lambda with receiver. You actually has the t not as parameter but as this inside the block. So you can use the person object inside that block without writing person and without receiving it as a parameter, but it is just a receiver in that lambda. And this and this does exactly the same. Yeah. And this language construct is the heart of Anko because it makes the layout definition concise and clear and easy to follow. Okay, can switch. Oh. Okay, so if you go to GitHub page of Anko, you get this very simple sample code in the README file, but it gives us the idea how it will look like creating your layout from code, not from XML. Actually, here we create a vertical layout, which is basically a linear layout with vertical orientation, and then we add an edit text and the button, and we actually registers an on-click listener, and when we click the on-click listener, it raises a toast. Yeah, it looks like as if it was JSON. I'm not sure if anybody is familiar with QML. It's the language definition DSF or Qt, UI definition language. And it is pretty much, it looks like the same, but it's not a DSL, but actual real code. And it is type safe and so on and so forth. I cannot switch easily. Okay, so why would you want to use Anko over XML layout for Android development? Because it is type safe and no safe. It has compile time validation because you are actually writing code, not just a DSL. You don't have the context switch between the XML and the fragment or activity or view, where you actually have to get your views and set up them with click listeners, or set up some asynchronous task and inflate the result to the layout. But you can mix your layout logic and your view logic together. And it is actually faster than XML because there is no runtime parsing of the XML file. It is not much, but worth noting. Also, because it is code and not XML, it's easily reusable. You can create methods of it and can use them everywhere. Also, these on-click listener registering and configuration can be reused. In XML, you can only just use include or merge tags, which provides some reusability, but not the real thing. Actually, it is really concise, as you have seen. And this is my subjective opinion. It looks just better than XML. I like reading JSON style text more than XML. Okay, I try to switch to the next slide. Doesn't work. Oh. Actually, I have no idea why is this happening. Okay, so why would you not want to use Kotlin, Anko? Sorry, because it is obviously not Android standard. You can't find many samples or issues or Stack Overflow threads upon it. The other part is that you're betting on Kotlin, so you are actually wiring your layout definition to the Kotlin language, and you have to be, it is not a problem, but you have to be sure that you want to go with Kotlin development in your Android application to build your layout in Anko, because Anko can be used in Java, because every Kotlin code can be used in Java, but it loses all its clean functionality there, and it is basically useless in Java. Because it is not an XML but code, obviously it's slower to build when you change it, slower to build your application, actually Anko has a DSL preview plugin for Android Studio, so you can actually see your layout while you're programming, but it has a lot of issues right now. At least I couldn't make it work for the latest release of Android Studio 2.0 or 2.2. And also I think Google just broke their interface of the preview plugin, and Anko should be updated to use that. And the last thing is that I've seen that the repository is not so active. There are a lot of open issues, and while this is not a huge library and not a complex library, one could easily fix the issues themselves. It is not that active at the moment to use for large projects, and maybe it will be just stopped. So, I'd like to talk about what happens when you're actually writing this code. It looks like magic, but how does it work? So when we are writing this vertical layout in the code, we can't write it anywhere because it is an extension method over View Manager, as we will see soon. My slide, if I can get to my next slide. Everybody had this problem or just me?
Just you.
Okay. I feel special.
No worries, happens to everyone.
Just get a Mac.
It's a Mac.
I bet it has Ubuntu installed on it.
Yeah. It actually worked on my Windows, so yeah, I'm trying. It doesn't work either. Oh, okay. It started. Now it stopped again. I'm sorry. Okay, thank you very much. Thank you. Yeah, so far it works. Okay. It stopped again. So maybe I will just use the key. Oh, it doesn't like one of my slides. It seems.
Tell a joke. Tell a joke.
It started to work again, so I can continue instead. Okay, so can you see it? Okay, so as we can see this vertical layout is actually an extension function over the view manager. Actually, Android view manager can be a lot of things because it is an interface. Activities are view manager, view groups are view manager, and there is this special construct in Anko called Anko context, which is a view manager. So you can write this vertical layout in a lot of places, in your activity, in your view groups, in your special context, but not everywhere. And when we are writing it, this is a method. And it has two parameters. One is a theme, so we can theme our views. Every view can have a special style or theme as used in Android. And also the second parameter is what I have been talking about, this lambda with the receiver. We actually have this lambda with receiver over the underline linear layout. That block, which comes after the vertical layout, is actually the last parameter of this method. Just Kotlin hide the parentheses, so you don't have to write parentheses if your last parameter is a block or a lambda. So inside the block, you actually have this underscore linear layout as the this. So it is the receiver of that block, and you can define operations on the linear layout itself. And this Anko view is also an extension method over the view manager, and it actually has this factory, which basically just generates this linear layout for us in the first place. And when we call that method, it creates a context if we are not the good context in terms of style, and then it factories our view, so it generates a linear layout or button or text view or whatever we set up, and then it runs our lambda with receiver. I tend to think about this lambda with receiver as an anonymous extension function. So it runs our block, which is defined over this type. So, and then after all, it puts our view into the current context. It depends on whether we are in an activity, then we put our view into the activity via set content, and if we are in a view group, we just call the add. That's how it works. So this is a sample here where we define two different types of layout with a button, and we want to set the layout parameters of the button. This is a well-known construct in Android, and you have to take care of it. And this is why these underscore linear layout and underscore relative layout classes are generated to be able to do this, because these two alparams methods looks like the same. They are both an extension function over the button, but inside one of it has a relative layout params as a receiver, and one of it has a linear layout param as receiver. And while you can write align parent top when you are inside the relative layout and use this params method, you cannot write it in the vertical layout because it is a compile time error, because the code actually knows that you don't have a relative layout outside, but a vertical layout, and it is achieved by generating these underscore linear layout and relative layout classes. And the idea behind of it is that actually in Kotlin you can have class scoped extension functions. So while in C# the extension methods are global and you can use them everywhere, here in Kotlin you can scope them. So this parameters extension method is defined in the underscore relative layout class, and you can use it just when you are inside the relative layout. And because we had this lambda with context, we are actually inside the relative layout in this block. So we have this params extension function over the underscroll relative layout, and when we are inside the vertical layout, we have the other method. So these methods are not the same. Actually, I developed a pretty simple sample application just to showcase what Anko can do for you. It can be downloaded from GitHub. It uses RX, Kotlin, and Retrofit to download some users from GitHub, and you can click a button to visit their GitHub page. And let's start to write this application. First of all, we want to structure our application. We want to separate our UI code from our activity. We are using this Anko component. We use it just because the Anko DSL preview plugin uses this interface to find your UI so it can present it to you. And it has only one method, this create view, which actually generates a view and have this Anko context as a parameter. This Anko context is a special view manager that is defined in Anko, so you can write your UI logic even when you don't have, when you are not inside an activity or a view group, but you have the context. So we can wrap our context, and then we are in an Anko context, and we can write our layout code even when we are not in a view group. First of all, let's inflate a toolbar. So we have this vertical layout, which is a linear layout, and then we add an app bar layout, and we set a theme on it, we set its title, we set its background, and actually with this UI owner, the Anko component has the type main activity, so our owner is the main activity. We can call the main activities methods. So we can call this set support action bar this. So we actually also set up our toolbar in our activity via this code. And then we set the layout parameters and create an empty frame layout for the next. And it looks like this. So it's pretty concise. In XML it's much more code. We don't have to write a lot of code which can be guessed by the framework. We want to add the menu item. I couldn't find any methods in the Anko which supported the menu item, but I wanted to do it by code, so I created some sample Kotlin methods. Obviously, we could extend Anko with this kind of TypeScript builders to support the menu item as well. But here we just set a name and an icon, and we will set a non-click listener on the menu item. The really interesting part of it is when we are actually downloading the users from GitHub. This code goes into this empty frame layout. We actually start our asynchronous GitHub call right in the middle of our UI generation code. This is a bad pattern, do not use it. You should obviously have presenters and handle this stuff properly, but I just wanted to show how powerful Anko is. Actually, we start our asynchronous call, and when we get the result, we inflate vertical layout here, and we can iterate through the result, and for each result item we can actually inflate a text view inside this linear layout. So what we have done here, we actually written a for loop into the XML layout of our application, and it will present all the users coming from GitHub. The UI is not fancy here. I just wanted to show that we can have this item in the list. And the power of Anko is that we can actually have control flow statements, we can actually multiply or add different dimensions and can define dimensions. As for me, I wanted a million times in XML as if I could write this 20 dp plus 20 dp, for example. You can do it with ease in Anko, but you cannot do it in XML. So we can define our custom views. So let's create a GitHub user view, which will have only a picture and a name and a button here. We actually will use the GitHub user model and generate the code, generate the layout when actually model arrives. So the init view function defines the layout. So here again we define an image view, and then we immediately can initialize a glide, which is an image loading library, to inflate or download the image into our image view, and asynchronously, obviously. So in the old way, you should write the image view in the XML, and then in the activity you would have to find view by ID the image view, and then with glide you have to load the image into it. Right here it happens the same time. Also we set up the layout parameters, we create the text view, and the button, it's not written here because it's not relevant. Of course, what we have done in the previous slide, when we are actually running a for loop over the result, is not a really good idea, because it is not reused, those components. It's you have to go with the old recycle view if you want to have these long lists with thousands of items. So we can reuse those elements. So let's create a recycle view. Here we can see this Anko context, what I've been talking about, because we don't have, we are not inside a view group and an activity here, so we have to create a view manager block where we can write our layout code. We write our custom view here, and then we are setting up an ID for it. So when we are creating the view holder, we can actually find our view inside it. And we can't use the params here as well, because we are actually not in a view group, and we don't know what is the parent view group type is. So we can't rely on it if it's a relative layout or linear layout. So we either know what is it exactly, or we can instance off the type and handle it properly. Right now we set up only margins, so it doesn't matter. And actually the first code wouldn't even compile because our custom view is not known by Anko. We have to extend Anko with our custom views. So we have to define this extension method over a view manager to be able to write it down. But this is the same as we have seen with the vertical layout or with the other components coming from Android system. Using styles is also manageable in Anko. First, we can use standard Android styles with the theme I've already mentioned, and we can have these setter blocks or setter lambdas over the views where we can do whatever we want. Basically, it can either be applied on one view or recursively on a view hierarchy, but it has some drawbacks. That if it is a one-shot thing, so if we run our style over a layout hierarchy and some view gets added after we run the style, it obviously don't get the style, so it doesn't work like Android style and theme system in that regard. And also the latest defined styles override the local one. I'm gonna showcase it here. So here we have this button. We want to have this green style over text views. So we just write apply, and we set text color is green. and it gets green. It's totally okay. So this is the style basically here. And the other part is that we are actually inside the horizontal layout, and we create a recursive style over the horizontal layout, and we said if you find a text view in this view hierarchy, let it text color be red, and it actually overrides the green because this block is running later than the inside block because it runs when we're generating the button, and then when we generate the button, it gets added to the horizontal layout, and then it causes a prior recursive function. So it gets red, not green, and it is something what maybe you didn't want. So you have to be clever about applying styles in this manner, or you have to fall back to the standard Android styling because it works as you want to work it. Obviously, one of the main power of the XML layouts is that it can handle different configurations. It can handle landscape mode, it can handle different device display density, API level, and whatnot. So Anko can do the same because we have these configurations called lambdas. So it is obviously an extension function over the context where we can define our rules. So for example here we want to run this block only when we are in a landscape orientation. So we can state here we want landscape orientation, but Anko supports a lot of configuration, the same as XML, like device density and so on. So this code states that if you are in landscape mode, we also put another text view in the layout, a green text view. It's nothing interesting. It just shows you actually can branch your code depending on configuration. And you don't have to replace your whole layout logic. You can replace just specific parts. So it is more useful than, more powerful than XML, which can only be replaced by whole or altogether. Nothing. I mean, not the 100% of the Android layout system is covered by Anko because there is something that cannot be achieved, or it's really hard to achieve by code. So probably sometimes we'll have to fall back to standard Android XML. And also we don't want to rewrite all our layout if we want to introduce Anko into our currently running project. And we can do that with ease with Anko. So let's replace the last text view we just added with an XML. It's a plain old XML here. And we have this include method where we state we are gonna have this text view typed layout inflated here. We add the XML, the ID of the XML, and then we also have this block when we can configure or set up our text view further. So we just didn't create the text view here, but we can set up here like the other parts of the Anko code. And that was it about layout building. I think everything is achievable in Anko. Not everything is implemented yet. There are some issues, but the code is really not complex, so everybody can start hacking around and create pull requests on the repository. And it is pretty fun to write layouts in this manner. But Anko is not just about UI utilities. We also have an intent builder function where we can create a new intent with this concise, easily readable manner. We have this key and the value, which we put in the extras of the intent. Also, we define our activity type, and the new task is actually setting a flag on the intent. So it's easily readable and much more concise than the usual way. A little interesting thing here is that the two keyword looks like as if it was keyword in Kotlin, but it's actually not. It's just an infix function. When you have two parameters, you can make that function infix, and then it looks like as if it was a keyword in Kotlin to be easy to be more readable. And two just basically a method that creates a pair. We can also build alerts and toasts with pretty much the same technique than UI layout. Here we also hide the Android boilerplate of creating alerts and toasts, and it's pretty straightforward and looks like this. Also there is a simple asynchronous pattern implementation in Anko, so you can actually write this do async, and the following blocks runs on an executor thread, which is by default a thread pool, and then when we are done, we can write UI thread, and then it gets dispatched back to UI thread, and we can handle our code. Also, we can provide an exception handler like in the sample, where we can handle the exceptions, but be aware that the exception handler is running on the background thread you're actually on, so if you want to handle the error on the UI thread, you have to dispatch back to UI thread. So here what happens, we actually sleep 3 seconds, then we throw an exception, then we handle the exception, we provide a toast that something bad has happened, and we start to wait another 3 seconds, and then we create a toast again. And waiting is not on UI thread. We have also a bit better logging support with Anko by using this Anko logger interface, which is an interface but has a method implementation, because in Kotlin interfaces can have method implementation which doesn't have side effect on the class. So basically what we get here is we don't have to find out the tag of the class, and it is handled by the Anko logger interface, and you just have to write error, the message, the exception or throwable, and all the other stuff is done by the interface itself. There is this SQLite library of Anko. It is a pretty great wrapper on the SQLite. It hides a lot of boilerplate and complexity of handling SQLite requests. Also introduces some type-safe features over SQLite by making the types and whatnot typed. And it helps actually keeping the right patterns by providing these lambdas with receivers, so you can actually just write your code, and you can be sure that when you open your data connection, you actually close it in a finally block, but you don't have to write the try finally block over and over again, because it is done by this framework. But it's a really extensive library, and it could make another talk to go through all of its features. And that was all I wanted to talk about, and I'm open to questions.